Hey everyone, before I get started with this particular section, I wanted to give you a sneak peek what you are going to learn in this section. We will start with the Gemini 3 and the LangChain Bootcamp introduction. I'll give you overview of the Gemini 3 model and their pricing, and also I'll give you overview how Gemini 3 model is better than the Gemini 2 models. At the end of this particular section, you are going to achieve something like this. You will be able to generate here infographic image, something like this. We will be using Google's Nano Banana Pro model along with the Google Gemini model, which we will be using later on. Before generating this, which we will be using to analyze our PDF file. After we get the analysis, then we will pass those analysis to Google Nano Banana Pro model, and then we will be generating output something like this. As you can see here, I have generated multiple output, and these images are really awesome and stunning. Let's go ahead and see what else you are going to learn here. We will start with the basic usage. We will explore all kind of the AI messages, output, response, etc. I'll be also explaining you all of these things using a block diagram here. This will explain you that how the thing works here with the Google Gemini models. I'll also explore here multimodal capabilities of the Google model, and then we will see here that how you can analyze the image, how you can analyze the PDF files, and then how you can use tool calling capabilities. We will also see later on how you can use the inbuilt tools, how you can control the reasoning capabilities. A lot of things you are going to learn. At the end of this section, you are going to finally generate an infographic image, something like this. In this infographic image, you will notice all the data which you are seeing here. We have analyzed previously in this notebook, and that analysis is coming from here. We will be using here, the caching as well. So the context caching is also very important part of this section. All these things we are going to see, we are going to learn in this section. Let's go ahead and get started with this. Hey everyone, welcome to Gemini 3 with LangChain Bootcamp. Recently, Google has launched Gemini 3 model, and it is one of the most advanced model launched by any major AI companies like OpenAI, Google, or Anthropic. Gemini 3 model offers a lot of new features over the Gemini 2.5 models. For example, Gemini 3 offers very advanced reasoning, and also it can process 1 million tokens in input prompt, but it can generate only 64,000 tokens as the output. Other than that, this particular model is very good handling in handling the multimodal data. For example, it can handle image, PDF, audio, video, and also it can handle all these things with very granular level resolution. Basically, as a user, you will be having very high control over its resolution. Other than that, its knowledge cutoff is January 2025, and it can generate image with the resolution up to 4000 4K, basically image resolution. And it can also ground the image resolution. Basically, what it can do here, it can also do internally a Google search before providing you the answer. So Gemini 3 also offers this particular feature. All right, behind the scene, you can enable the Google search. So how this Gemini 3 model will be working there, let me just quickly tell you here that let's say this is your Gemini 3 model. All right, and your user query comes in here. Gemini 3 automatically does there behind the scene a Google search here. All right, and then this Google search goes there here, and let's say here is your user query which comes in here, and then finally it can produce the grounded response. So here is your query. This query also goes to the Google search. Let me just quickly tell you here that how it is going to be there. Let me just do it like this. Maybe it would be better like this. And then this Google search response goes to the Gemini 3, and then finally you get here a grounded response. So all these features are inbuilt with the Gemini 3. In fact, these features also comes with the other models as well. But as we are moving forward with the Gemini 3, it offers a lot of more, the accuracy and the control over the previous models. Here are some of the advanced model variants provided by the Google. For example, Gemini 3 Pro preview model. So you see there, this is a preview. That means Gemini 3 is still in a preview model. That means once Gemini 3 model comes out, basically a full model comes out, it would be a lot more better than the current model. There is also image model, Gemini 3 Pro image preview model, and this particular image model is also known as a nano banana model as well. The other models are like Gemini 2.5 Plus model and many other models. Here are some of the advanced features which Gemini 3 offers. For example, a thinking level. So with the Gemini 3, we will be controlling our thinking level with the like reasoning depth like low or high. Low reasoning depth means it will be consuming low or less number of the tokens while thinking. With the high setup, that means it is going to think a lot before it answers. Then there is the media resolution. That means you can control how good you want the image, for example 1K, 2K, 4K, etc. Or if you provide video or audio or let's say the image as an input to the model, then you can also provide that what should be the parsing what should be the parsing resolution. Basically, if you select the low resolution, that means your image resolution will be reduced before passing it to the LLM. If it is high resolution, that means your image will be passed with high resolution for the LLM. High resolution means more number of tokens it is going to consume. Then you have a temperature setup. So one more thing you will notice here in this case with the Gemini 3 model, especially with the Gemini 3 Pro preview model and going forward. So temperature setup is almost removed from the model setup. Earlier we used to do the temperature setup and top K, top P values. There are so many LM setups or LM configurations we had to do, but with the Gemini 3 models we don't need to do that, because by default it comes with the default value 1.0, and you can keep this as a default. You don't need to change anything. That means nowadays LMs are coming, good quality of the LLMs are coming out of the box. You don't need to do a lot of setups for the LLM. Thereafter, a very important part, that is the thought signature. Automatic reasoning context preservation is provided by this thought signature. Once we move forward in this particular section, then I'll be explaining you what is this thought signature and how this LLM is providing this thought signature. This is really very important, especially in case of the tool execution. Once you finish this whole section, you would be super comfortable going forward this course. All right, let's go ahead and get started with the setup. I'll see you then. All right, now let's go ahead and get started with our notebook setup. In our previous video, we have seen Gemini 3 overview, and we discussed that what are the additional features of the Gemini 3. Now it is time to do the setup. So first of all, you need to come here. Let's try to understand that what we are going to use with the Gemini 3. One thing we know that Gemini 3 can use the Google search automatically. That means this is like an inbuilt feature with the Gemini model. With the Gemini 3, along with that, the Gemini 2 model also offered this internal Google search itself for the response grounding. But you can also add the additional tool if you want. So we'll be building here a couple of tools which we will be attaching with our Gemini models so that we can test our Gemini models tool handling capabilities as well. So what are those models? We are also going to implement here a web search tool. So that is going to be the external web search tool. Let me just quickly write that. External web search tool. Seems like something is not right here. All right, yeah, here it is. So we are going to use here web search tool. And in this web search tool, we are going to use here Ollama web search tool. All right, so this is a free web search tool, and that is offered by the Ollama itself. Thereafter, we are going to connect this with this one, and this is also going to connect with this one. Apart from this, we are also going to use here one of the Wither API here. So I can just simply duplicate this. I can write it like this. Wither API for the latest Wither update. All right, so we can do it like this and something like this. That means these are the two additional tools which we will be using in this particular section. That means we also need to create the API key for these tools. Let's go ahead and create an API key for these tools, and I hope that you have already created API key for Gemini 3 models. For example, if you want to create the Gemini 3 API key, I guess you have already done that. If you have not done that, you can come to the Google AI Studio and then you can click on Create API Key. All right. And then you can finally create your API key. we have already done the API key setup for the Gemini model. In case if you have not done, you can just simply come here, or you can create .env file here, and then you can place your Google API key like this. Create your API key and then place it here. Apart from that, you also need to provide your Langsmith API key, which we did previously. So this is how you can do your Langsmith API key, and then you can do your Langsmith setup, something like this. You might be seeing somewhere else like the LangChain tracing version 2 or something like that. But recently LangChain has launched the LangChain version 1 API, and from the LangChain version 1 API, they have streamlined all these things with the Langsmith. So instead of writing there the LangChain API key, they have started writing it as a Langsmith API key. Alright, having said that, now it is time to create the Ollama API key and Wither API key. So first of all, what you have to do here, you have to come here and search here Ollama API key. Alright, just do like that, and then you will click on here authentication. You might come here or somewhere like that. Seems like it is not there, or you need to come to here actually with Ollama, and thereafter you need to sign in here. Once you sign in, thereafter you need to go to the setting, and thereafter in the settings you need to go to the keys, and then here you can create the key here. Alright, once you create a key, give a name to your key, and thereafter you need to copy this particular key, and then you need to place your API key here like this. Alright, I hope that you have done this. Now let's go ahead and see with the API key. So what you have to do here, you need to come here into Google and search Wither API. Alright, like this, witherapi.com, search it here. Thereafter sign up for Wither API. You can click on sign up if you are fresh or you are new to Wither API. Otherwise, if you already have, then you can just simply go and log in this Wither API. So I already have account to Wither API. So I'm just going to log into this Wither API. And then I say, remember me next time. Alright, and then I'm going to log into my Wither API. Remember, if you don't have account to Wither API, you have to create your account. Alright, it is completely free to use. You don't need to give any money to create API key either on the Ollama or on the Wither API. Alright, thereafter you will get a free trial version here, or a free plan basically. Alright, then you can just simply come here and you will see here that these many calls we can call in free per month. Alright, with the Wither API. Thereafter you have to come here at the API, click on the API, and then you can just simply copy your API key from here. Once you copy this API key, thereafter you can come here and then paste your API key here. Alright, now you have your API key for the Wither data, and also you have your API key for the Ollama web search here. Remember, we are using here two type of the web search. One web search is coming from the Google search itself, that is provided by the Google itself. Others web search we can use here, that is the Ollama. And all these things are going to be used as a tool along with our LM. Why I am doing this? Because I just want to show you that how you can use the external tool with your Gemini models. Alright, because this Google search is quite costly. If you come here at Google AI Studio, not Google AI Studio, in fact Gemini API here, in the Gemini API, in the pricing part, you will notice here, if you just come to the pricing part, just scroll it down, one thing you will notice here that the grounding with the Google search is quite costly. 5,000 prompts per month is completely free. Thereafter, it is like $14 for 1,000 search queries. So this is really quite costly. Alright, so we have created all the initial level of the API key which we will be needing in this particular section. Now in the next lesson, I'll show you how you can load these environment variable in your notebook, and then we will get started with the coding part. I'll see you then. Alright, so we have created all the API which we need in this particular section. Let's go ahead and load our environment variable in the notebook so that we can get started with the coding part. First of all, we need to import our load.env so that we can load our environment variable. So I write it like this: from .env import load.env, and thereafter I can just simply write here load.env, something like this. If I just simply run this, you will notice it is true. Now you can verify that your API key is loaded here. Generally, we don't print our API key in the notebook just for a testing purpose. If you want to do that, you can just simply do like that. os.get.env, and then you can write your environment variable name, for example, like this, Google API key. And if you notice here, this API key is loaded, and this was our API key for a Google API key. Generally, we don't do this in the notebook, because if you print it like this and thereafter if you push this in the GitHub repository, your API key will be exposed. So let's go ahead and comment this line. This particular line is just for the testing purpose. Let's run this. Now you will notice here it is gone here. All right. Thereafter, it is time to also load our Google Generative AI library, so that we can connect our notebook with the LLM instance here. So first of all, what we do here, we write like this: from LangChain underscore Google Gen AI import chat Google Generative AI. Before we write this, let me just quickly tell you here, I hope that before you coming to this particular lesson, you have installed this requirements.txt. If you have not done that, go ahead and watch that particular lesson from the first section and install requirements.txt file. All the required library which we are going to use in this particular course, everything is given in this requirements.txt. You install that, thereafter you continue this. If you do not know about this code file is provided with this course itself. You can download it from the first section. Otherwise, you can come to my GitHub repository, Lakshmi Merit, and then you can download multi-agent deep RAG repository from there itself. All right. So we have imported our chat Google Generative AI. Thereafter, we also need to import here various kind of the messages which we will be using in this particular course. For example, we have our LangChain dot messages, import human message, system message, and the AI message. Generally, AI message and the tool message we will not use, because these are generated by the model itself. But I just wanted to show you these are the kind of the messages which our LLM handles. Now let me just quickly tell you how all these things are going to be executed, or how all these things are actually connected to each other. Let's come back to our block diagram here. So here is our Gemini 3 model. So this Gemini 3 model is actually our LLM. So I can say it something like this. So this Gemini 3 model is the LLM. Whatever user query comes in here, that user query comes here as a human message. All right. So this comes as a human message. Along with this human message, all these LLMs also have their a system message. So you can say that the system message also comes in from the outside, but that system message is actually optional. So let me just do it like this, so that I can, let me just do it like this, and here I'm going to do it like this, and then I can say that here is a system message, but the system message is actually optional. All right, so system message comes here. I'm just going to make it optional with some dash line here. Thereafter this particular, the LLM generates the output. That output is going to be the AI message. So you can say it something like this. Whatever the output is generated by this LLM, that is referred as the AI message. And thereafter, whatever data is returned by our tool, that is actually the tool message. So you can write it like this. This is going to be the tool message. So I can write it like this. Let's go ahead and keep these. I don't know how to do this. Let me see if I can do it like this. Yeah, here it is. So it goes like this. All right, so I just put here a little bit of space. Now I can adjust my tool message. So we have a tool message, system message, human message, and the AI message. Let's go ahead and change the color of these so that we can identify that these are the kind of the messages which we deal with our LLM. All right. And now, as a user, if I need to connect with the Gemini 3 model, then I have to use here a special kind of library provided by the Google itself. That is the Gen AI. And then Google Gen AI model is actually this. Basically, Google Gen AI library is wrapped by LangChain itself. So LangChain provides you a library, that is the LangChain Google Gen AI. That is the third party integration. In that we can use the chat Google generative AI. Press a control key on the keyboard and then click on here. Then it will lead you to the chat models. In the chat model, that is coming from the LangChain Google Gen AI chat models. In this chat model, you will notice we have to provide a Google API key in the environment variable so that it can automatically pass this to the Google generative AI chat mod. Thereafter, you can pass your model something like this, and then we can use our LM something like this. Later on in coming lessons, I'll show you how you can use all these things here. As you scroll it down, you can see here all the working principle of this model. Generally, you don't need to go with these documentation because I'll be providing anyway a step-by-step lesson in this particular section. So you learn everything from the very beginning, from the scratch to the advanced level. Let's go ahead and run this. And now you will notice this Google Generative AI is exported in your notebook. Now in the coming lesson, I'll show you how you can get started with using these library in your notebook. I'll see you then. Hey everyone, let's go ahead and see how you can use your Gemini 3 and Gemini 2 models with the LangChain. This particular lesson is going to be the backbone of this particular section. So let's go ahead and get started with, first of all, with all kind of the models available to us. We need to come to our Gemini API document. In Gemini API document, you have their pricing. Thereafter, at this particular side, you will see all available model here. You have currently Gemini 3 Pro preview model. At the time of recording this video, you might be having here some other model by the time you watch this video. Thereafter, we have another model, that is the Gemini 3 Pro image preview, that is the Nano Banana model. Then you have a Gemini 2.5 Pro model, Gemini 2.5 Flash model, and then you have a Flash preview model. As you go down, you will see here a smaller and smaller model. Generally, we don't go lower than Gemini 2.5 models. Thereafter, here you will be seeing the rate limits, but we need to focus on the pricing part. As you will notice here, for the pricing, you have Gemini 3 Pro preview model. Its pricing is like this. If your total number of tokens are less than 200k, then the pricing is like this: $2 for a prompt where it is less than 200k tokens for 1 million tokens. Otherwise, it is a $4 for a prompt where it is greater than 200k tokens. And then the output pricing is here. So it is like the output which it generates. For anything less than the 200k tokens, it cost you with the $12 per million tokens. And if the total utilization of the tokens are more than the 200k, then it starts here with the $18. Thereafter, you have the context caching as well. Once we start learning about the caching, then we will discuss these things. Thereafter, you have other models, like you have here 2.5 Flash model. In the 2.5 Flash model, you will notice there is a huge price difference, because in this model you have almost $2 to $4, but in 2.5 Flash model you have just $0.3. And here is the output pricing, which is the $2.5. And here the output pricing is like $12 to $18. So at least the 10 times there is a cost difference between Gemini 3 Pro preview and Gemini 2.5 Pro and Flash models. The one more thing you will notice here, Gemini 2.5 Flash model offers you a free tier usage. All right. Otherwise, you will notice here this Gemini 3 Pro preview does not offer any free tier usage. That means if you are currently in a free tier and you don't have a credit, then you can go ahead and you can use the Gemini 2.5 Flash model. You will not be able to use this particular model if you don't have a credit. But if you remember, in one of previous section, we had got our $200 free credit. So we are able to use here Gemini 3 Pro preview model as well in this particular course. Let's go ahead and get started with using these two models. So we'll start with Gemini 3 Pro preview and Gemini 2.5 Flash and Gemini 2.5 Flash model. You can select any of these models, whatever you prefer. So I define here, first of all, Gemini 3 is equal to Gemini 3 it is going to be like this. Gemini 3, and thereafter you have a Pro. And then you have a preview model here. Then you have a Gemini 2 model. So with the Gemini 2, you have here like this. Gemini 2.5, and then we are going to use here Flash model. So I have defined these in a variable like Gemini 3 and Gemini 2, so that later on I'll be able to get these model instances using these names only, because I don't need to write this whole name every time. All right, cool. Now it is time to write our system message. If you remember, in one of our previous video, we had discussed about the system message, human message. So the system message is like instruction to the LLM. The system message makes sure that your LLM follows a particular role, and here is the user query, and then your LLM generates the AI message. Let's go ahead and define the system message. We have already imported our system message here. All right, system message, human message, AI, and the tool message. So every kind of the messages we have imported here. Let's make our system message here, or prepare our system message basically. So we have it like this. You need to write here system message. In this system message, you can pass your content directly. So I'm going to pass here a simple content like you are a helpful AI assistant. All right, you can make your complex one later on. Once we move forward in this course, then we will see how you can make more structured system prompt. This is just for testing purpose. Thereafter, we have our query. Now you can prepare your query like this, human message, and then you can ask your question here. Like I'm going to ask here, explain the theory of relativity in the simple terms, let's say. All right, this is my query. Now we have our system message and the human message. Now we can combine these messages together. So we can write it like this. You have your system message. Along with this, you have your query message, that is the human message. All right, you have got your final message. Now it is time to get the LM instance using chat Google Generative AI. So we are going to get our message here. Let's run this. And now I'm going to write like this. We are going to get our LM instance here basically. So we write it like this: model equal to chat Google Generative AI, and in this we pass our model equal to Gemini 3. So the first time I'm going to pass here Gemini 3 Pro preview model. This is one of the most advanced model. Remember, this is quite costly model. If you are on paid plan, then use this model with the caution. Thereafter, we write like this: response equal to model dot invoke, and then we pass it like this: messages. Let's run this. Then it is going to call our, basically this particular LangChain API is going to call Google Gemini 3 Pro preview model, and then it is going to use, it is going to return AI message in the response. Later on, we will see this response will be populated with the AI message. All right, so let it run. We will continue this in the next lesson, where we will explore the output formats, and also we will see our LM tracing on the Langsmith. I'll see you then. So we have got the response from our Google Gemini 3 model, and this response is just super slow. Basically, it's super slow. As you see here, it took almost 2 minutes to give me a response for my simple query, where I ask my model to explain the theory of relativity in the simple terms. Let's go ahead and explore the response here. So the one thing you will notice here, the response message type is actually the AI message. So this is what I was talking about earlier. You pass your system message and the human message to your LM. LM returns AI message here. And also LM have ability to access the tool message when it is connected with the tool, which we will see later on. Now let's come back here. In this AI message, you are going to have here the content. Inside the content, you will notice here it is the list here. And in the list, you are having the type and the text. Basically, this thing what you see here, this is known as the content block, which we will explore in some time. But let's go ahead and first of all see our Langsmith, and then we will come back here. Do you remember one thing here? At the start of this particular course, we had done the setup for our Langsmith, where we discussed that how we can enable our agent and the LM tracing. All right. So it is time to go ahead and see our Langsmith tracing. So you need to come to your Langsmith projects here. In the Langsmith projects, you will be having here a tracing projects. In a tracing projects, you will get your project name here. So this is exactly the same name which you have used in your dot environment variable here. That is the multi-agent deep RAG. Now I'm having here multi-agent deep RAG. Let's click on here. Thereafter, you can see your latest trace here. So this is one of my latest trace here. If you notice here, my input question was here, you are the helpful AI assistant, and then explain the theory of relativity in the simple terms. And if you notice here, it took almost 122 seconds. That means it took almost 2 minutes. And here is the model which it used, Gemini 3 Pro preview model. All right. So this particular thing says that it was really quite slow. And here it says that the total number of the tokens in input, it took almost 18 tokens to process. Basically, these things are combined. I mean, this system prompt and the human message combined together was I mean, they had less than 18 tokens, and the output it generated, that was the 1.6k tokens, and the total cost here is less than $0.01 for this one and $0.02 for this one. Now again, if you remember, we had done our setup for the pre-credit, so everything is getting consumed by pre-credit itself, so you don't need to worry about that. And then you can see here is the output. In the output, you have your AI message here, and this is a pure AI message. Now you are not seeing any kind of the metadata and other stuffs. Now if you want to see the metadata and other stuffs, what you can do, you can double click on this, and then you can see all the metadata for this particular call. So here is the metadata. And the metadata, you will notice this is the total this is the total cost for everything actually. Let me just see that if we can see the metadata for this one. Yeah, now we can see the metadata for this one. All right, so it says that these are the total number of the tokens, and here is the total cost and total the latency is here. Now if you click on here and then see the raw output, with the raw output you can see everything here. All right, and then you can see every output in your, I mean, everything in your output with the YAML file here. So you have a generation here, finish type is stopped. That means it has naturally stopped. And then here is the model name, and here is the everything which, I mean, which is returned by this particular model. As you scroll it down, here is the signature. Now, do you remember one thing when we were discussing about the Gemini 3 LangChain Bootcamp notebook? At the start of this, we discussed that there is a feature of this Gemini 3 model. They provides their signature. All right, so here, this is the signature. So whatever the response is generated by this Gemini 3 Pro preview model, they also generates a signature. This signature is very helpful in multi-turn conversation, basically in the chat bot where you keep chatting with your model. So with the help of this signature, your model will understand that what it has thought previously and what was its output previously with the help of this signature. Thereafter, you have here text. This is the final text which was generated by the LLM, and this is quite large text here. You can also control this text generation by using various parameters like the token budget and other things, which we will see later on. Otherwise, you can control this with the system prompt itself. Thereafter, you can see here the total number of the tokens consumes, and then it took the total number of tokens for the reasoning. So it took almost 899 tokens for the reasoning, and for the output, it took these many tokens here. All right, and then you will see here all of the stuffs. Generally we don't need to use everything, but this is the overall essence of this particular AI message here. This is what I wanted to show you in this particular lesson. One more thing I wanted to show you here in this particular response. So you have this response. This is the AI message. All right, If you scroll it down, whatever we have seen there at the Langsmith, you can see everything here itself. All right. So everything is here, basically everything. So you have your token details, everything. Now, if you want to see all these things in the detail, then how you can see this? First of all, what you can do here, you can write here response.text. So with the response.text, you can see only the text data, which is generated by your LM. So this is your text data. Now you can just simply print this text data so that you can see it in more better way. All right, so this is your response text data, and this response text data is really quite large. This is one way to see this. Let's go ahead and comment this, and let's see what else you have here. So you have also other things, like you have a content here. So if you see with the content, you will notice you are getting a content as a list here, and in the content you will be also having here, the type of the content. Currently we are having here text content. Later on we will see also this content type can be changed to the image type as well once we use the Nano Pro Nano Banana Pro models. Thereafter there is the text, and in extra you will be having here a signature. Other than this, you can also use the content block as well. So you are going to have all the content blocks. That is going to be something like this. So this is your content and the content block. So the one thing you will notice here, in the content and the content block, you are getting the same output. Don't worry about this. Currently you don't see any significance between these and these, but later on, once we use other kind of the models, then I'll show you the difference between the content and the content block. So this is something which is introduced by the LangChain recently with their LangChain version 1, because there were many models from the OpenAI, from the Google, from the Anthropic, DeepSeek. Every model generates their output in different form. So LangChain, what they did here, they provided here a uniform content block. So it doesn't matter what type of data is being generated by any kind of chat model, everything you can get as a uniform output using the content block. All right. So whether you are using OpenAI, Anthropic, or whatever, now with the help of the content block, you can get this similar kind of the output. All right. All right. So it has been almost 7 to 8 minute, quite long video. So I'm going to stop this, and we will explore this. We'll explore this with the Gemini 2 models as well later on in the next lesson. I'll see you then. Alright, so we are exploring AI message and also the content and the content block. We explored this with the Gemini 3 model. One thing we also noticed here, that Gemini 3 model is really quite slow. Now it is time to test with the Gemini 2 model, and then I'll show you what I wanted to tell you for the content block. So what I do here, basically everything is going to be exactly the same. Nothing is going to change. Only these things are going to be changed here. So I just copy here, and thereafter for this particular model, I need to provide my Gemini 2 model, and then I get my response here. That's all I have to do here. First thing basically you will notice here that the response is going to be super fast for the Gemini 2 model. It is not going to take like 2 minutes like we saw in our Gemini 3 model. The other thing you will notice here, that response, content, and the text, everything I'm going to show you, and then I'll explain you the difference here. So now you have your response.text. So you will notice here it is exactly the same like we saw here. Thereafter, we are also going to see here response.content, and with the response.content, now you are going to see it something like this. Now you see the difference here. So with the Gemini 3 model, what happens here? With the Gemini 3 model, Google has started giving all these details as well, like the signature and other stuff. Because of that, LangChain had to make the adjustment so that they can provide you the output in the form of the list and the dictionary. Now, in the previous models, like the Gemini 2.5 models, these things were not there. Because of that, it used to produce the output something like this. So what LangChain did here, LangChain actually added here one uniform property, that is the content block. Now with the content block, it doesn't matter what type of model you are using behind the scene, every model is going to produce the output in this particular format. Let's go ahead and see this format here. So if you write it like this, now you can notice you have got this particular format here. So you have a type here text, and the text is here. Signature is not present with this particular model, so signature key is not available there. But overall output format is preserved here between the models like Gemini 3 and the Gemini 2 model. Now you see the beauty of the LangChain here. All right. Excellent. Let's go ahead and explore other stuffs basically with the response here. So if you notice in the response, you will be seeing a lot of stuffs with the response here. So you have like the metadata and so many other stuffs. Let's go ahead and explore all these metadata. All right, so all these things here. So how you can get all those things? You can basically write like this: usage metadata. With the usage metadata, you will be able to know that how many tokens it has in the input. 18 tokens was there. In the output, it generated like 2700 tokens or 2800 tokens approx, and then there is the total token. So basically it is going to be the addition of this token and plus this token, and then there is no cached tokens, and then it used almost 1627 tokens for the reasoning. That means it has also done there the reasoning as well. Other than that, you can also use here the response metadata. With the response metadata, you can know here that what type of output, I mean how the output was produced basically. So there is, first of all, prompt feedback. It says that block region is 0. That's mean it did not block the prompt. Basically, prompt was very much safe. And finish region is stopped. That means it has naturally stopped. And model name is being used here, Gemini 2.5 Flash model. And then other stuffs are here. All right, like model provider, like a Google Gen AI model. All right, so all these responses are here. Let's go ahead and see this on Langsmith. Now you can see the tracing of this particular call as well here. So you will notice here it took almost 16 seconds here, and these many tokens it has used here, and the cost of using this particular model is really quite low. The total cost is $0.007, and here it was like $0.02 almost. But don't worry, anyway we are already using the free credit, so we are not getting charged in any way. All right, now you have your system prompt and then the human prompt or human message, and here is the AI output. So this is the final output produced by the AI. Now you will notice here that there is not a much of the difference between the quality of the output. So which particular model you need to select? Now based on your question complexity or the task complexity, you can select the model. For a simple questions, you can select the simpler model. For a very detailed task or for a very deep task where you need a very deep reasoning, then you can select these kind of the model like Gemini 3 Pro preview model, which is really costly. Along with that, it is really quite slow. All right, so as per your requirement, you can select a particular model. All right, excellent. So this is all about in this lesson. I'll see you next one. All right, let's go ahead and see how you can stream your model's output. Previously, we have seen our model had generated these outputs in one go. All right, it has waited till the time it has generated everything, and then finally it gives the final response. Let's say if you want to reduce the perceived latency, then you can use the streaming. So streaming is very simple process. What you have to do here, you just need to get your model. So this particular model is already using our Google Gemini 2, but if you want to get a fresh model, you can just simply copy this and then you can paste it here. Now we have got our Gemini 2 model. Now we are ready to stream. Let's go ahead and write here a simple query. So write here a very simple query. First of all, I write it like this. Query is like this. Explain the theory of relativity in the simple terms. Let's say this is my question, and now it is going to relativity. It should be like this. Okay. Now you can stream this output. So how you can stream this? Like this: for chunk in model dot stream, and then you can pass your query here. Thereafter, you can start printing your chunk here. First of all, I'm going to print my chunk, and then you will see the difference here. Once I print a single chunk, and then I'm just going to break. Let's go ahead and see how it generates the output. And then we will explore, basically we will complete this code here. All right, so it has generated here the output. As you can see, this output seems like quite large output with the streaming of the LM. So nowadays what LM does here, they actually generates, a small chunk, and thereafter they output that small chunks here. So that is what you can see here, that it has generated this output, but this output is really very small chunk. And if you notice here in its usage metadata, input token is this much, output token is this much, and the total token is this much. But if we if we remove this break, then we can see this whole output. So what we are going to do here, we are going to remove this break. Thereafter, we are going to print this whole chunk, but in different way. So what we'll do here, first of all, we are going to print our chunk with the content itself, and then we are going to plus its output. So how you can do that? Chunk dot content, we can do it like this, chunk or dot content. Otherwise chunk dot text would be much more better way to do this. And then you have end is going to be like this, and thereafter we have plus equal to the true, so that we can flush the input out standard input output buffer. So we can do it like this. Let's run this and then see its output. So what it is going to do now, it is going to print many output, and you can see the output in the running way, as you can see here. All right, as it is printing here, do you notice this? So it is streaming its output, and we saw that, right, how it was streaming this output. Now you can see this whole output here. All right, so you have this everything here. All right, everything is here. Excellent. So this is how you can stream your output, and this output really looks good. Overall, the things are pretty much straightforward, and this really looks good. All right. So this is all about in this lesson. I'll see you next one. All right, let's go ahead and explore the multimodal capabilities of Gemini 3 model. It supports the image, it supports the PDF file, audio file, video file, along with the text files. You can process these multimodal data either from the URL, or you can store it in your local directory and then you can use those. Let's come back to Google Gemini API document, and here at the right side you will see all the models which it has currently at the time of recording this video. And this side you can see all the model and their capabilities. Like you have capability of the text processing, capability of the image generation, video processing, then the document processing, speech and the audio processing, then thinking and thought signatures, and there are so much more. All these are the core capability of the models. If you click on the image, and then you have here image generation, there is the banana icon there. That means this is a nano banana. All right, and we also have a Nano Banana Pro model. Nano Banana Pro model is Gemini 3 Pro Preview model, or Gemini 3 Pro Preview image model is also known as a Nano Banana Pro model. Gemini 2.5 Plus model is known as a Nano Banana model. As you scroll it down, you can see its usage and it's a quality output. One thing you will notice here, that the quality of the output produced by these models are really awesome, and these are really super cool, the output here. All right, let's go ahead and make it like device default so that we can enable here a dark theme. Let's come back to our code. So we are going to explore these multimodal capabilities. First of all, we are going to explore our capability for the image. And then we will explore the capability for the PDF data, and rest of other things are out of this particular course scope. So we will focus on image and the PDF documents only. Let's go ahead and create our model first of all. So I write it like this: model equal to chat Google generative AI model. And here we pass our model, that is the Gemini 3 model. That means Google Gemini 3 Pro Preview model. Once you have this, then you need to prepare your human messages. Now, you need to understand here one thing, that in the image generation, this is actually image generation, but in the text one, you will be having here its multimodal capability. That means it can take the input data, and also it can take the text data. Along with that, it can also take the image data. Once it takes these two kind of the data together, then these kind of models are known as a multimodal. All right. So what we do here, as you scroll it down, you will see here in your multimodal input, you are going to have here image, and the type of image is going to be the PNG, and then in the content you have this image. Along with that, you also have the text data. That means to work with the multimodal capabilities of our model, you have to write here your human message. Let's prepare our message here, and then we will pass this to our Gemini 3 model. So I prepare my human message here. I will write it like this: human MSG, that would be better name here. And then you have your human message. Now this human message is now going to be the list of the dictionary. So first of all, we are going to provide here type. The type is going to be the text here. That means this is going to be my question here, or user prompt here. And then you write here text, and then you write your prompt here like this: describe the image provided. Now in next dictionary, you need to provide your image here. So you provide your image, and this time the type of this content is going to be the image here. And thereafter you pass your URL here. So URL is going to be like this. For an image, you pass your URL, and now you can use the URL from the internet. Let's go ahead and get one URL from the internet. So I search here some pandas image, let's say. All right, and then I can get any of these pandas image. This is something which I really like. So I just right click, and then I get image address from here. Once you have image address, then you can paste that in the URL. So here is image address, and then here is our question. That's the user question. So by combining all these together, you have got your human message. Once you have got your human message, then you can just simply pass it to your model. You can pass it like this: model dot invoke, and then you can pass your message here. That is the human message here. Currently we are not passing our system message, but if you want, you can pass your system message as well if you prefer. All right, so you have your system message which we created earlier, and then the human message. In the human message, your user query goes here. Along with that, your image URL is also passed here. Then internally, LLM model automatically download this image from the internet, and then they answer your query here. Let's go ahead and run this. Once it is done, then we will explore our response. Now the response is generated here. One thing you will notice here that I had to run it one more time. So what happened in the previous run, actually, in previous run, everything was exactly the same like this run, but our AI was not able to generate any output. So what I did there, I ran that particular cell once again. Thereafter, our AI is able to generate the output. So something like this, if you face issue something like this, then what you have to do here, you have to run it one more time. So I ran it. The next time I got the output, and in the output now I can see here, based on the image provided, here is the detail. Let's go ahead and print this and then see the detail output here. So I just run it here and then see the detail output here. Like image features an adorable cartoon style giant panda sitting upright, etc. And here all the details, etc. And seems like this is everything. This everything is like what is shown in the image itself. All right. Perfect. So this is the multimodal capability of the model. Gemini 3 is also able to handle this, and also your Gemini 2 model can handle the same kind of the input, and your Gemini 2 model also can produce the same kind of the output. So the Gemini 3 and the Gemini 2 both are multi-model handler LLM model. This is all about in this lesson. In the next lesson, I'll show you how you can analyze the image from the local file itself. All right, I'll see you then. All right, now let's go ahead and see how you can analyze image from the local file itself. The important part here that we are going to encode our image into base64 file or base64 format. Similar to image, you can also encode your PDF or audio file or video file data in base64 format, and thereafter you can pass it to the Google Gemini models. Alright, so in this base 64 format, there is a special type that is known as a MIME type. Let's go ahead and search that MIME type and then you will understand the whole thing. So you have here MIME underscore type for various files. Let's go ahead and search this and then you will get this result or any result you can open. So you will notice here there is a MIME type for various type of things here. For image you have MIME type something like this. Here it says that the type of the image. If you have a PNG then you have image / .png or BMP or whatever the MIME type you have here. Alright, so basically there is image and then the type of the file here. Similar to image, you have other applications like the PDF and other stuffs. If you notice here, let me just quickly search for PDF here. You have PDF here. For a PDF, you have application and the PDF. Alright, so these are the MIME type. This is something which we are going to use in this lesson for our base 64 encoding. First of all, we import our base 64 here. So we import it like this, import base 64. Thereafter, we need to write our image MIME type examples here. So we write it like this. First of all, MIME underscore type equal to image and then the / PNG. Why PNG? Because the image which we had analyzed previously, that is the PNG type. And that image I have stored here inside the data directory and then come to this images. Inside images you will be having this pandas.png. So this particular file I'm going to analyze here, right? It is the same file which we have used previously, so I stored it in the code file. So we have got our MIME type. Once you have your MIME type, thereafter we need to read this image and then we need to encode it into a base 64 format. Let's do that. So I write it like this, bytes. I can write it like this, image underscore bytes equal to open. Let's open this image. Where is this image? Inside the data directory, inside the images, and then you have pandas.png. This is where our image is currently. We are going to read it into a binary mode. Thereafter, let's read it here. Now we have our image bytes. It says that it could not find it. Let me just check here if everything is fine. Inside data, we have images. And then we have panda. Actually, it's not pandas, it's a panda.png. Now you have your image byte here. So you have actually loaded your image in a binary bytes format. Now you need to convert this byte into a base 64. So you write it like this, base 64 is equal to base 64 dot base 64 encode. And thereafter you pass your image bytes and then finally you decode it in UTF-8 format. Now you have got your image encoded into a base 64 format. If you check your image, you are going to get the output something like this. As you notice here, this is a string data and your image is encoded into a base 64 format. That means your image is actually encoded into a set of strings here. And this string is going to be passed to your Gemini model and then Gemini model is going to work on this particular string. Let's go ahead and copy everything what we had here. So everything is going to be almost exactly the same. So we copy everything, only the difference is here this one. Alright, we have our image here. Let's go ahead and this time load our Gemini 2 models. We are going to use here Gemini 2.5 Flash model and then question is going to be exactly the same. And the type is going to be the image and this URL is now going to be the different. Now instead of the URL, I need to pass here base 64 format. So for a base 64, I have here bytes base 64, that is my image base 64 string. Thereafter, I also need to pass here, I need to pass here MIME type, and in the MIME type, I'm going to pass my MIME type here. And the MIME type is image and the PNG. That means your Gemini model will understand this set of string is actually the image and the type of image is PNG here. Alright, so this is all you have to pass here. Once you pass this everything, thereafter you just need to simply run it. Now it is going to take a little bit time and then you will be able to see its output that is going to be returned in the response. In one of our previous video, we had seen how you can analyze image with the Google Gemini. Now let's see how you can analyze the PDF file with the Google Gemini. So we also saw there is a MIME type, and with the MIME type, you can define the type of file which you are sending to the Google Gemini. We send our file data encoded in a base 64 format. And with the help of MIME type, your Google model is able to identify that the type of data which you send as a set of the string. As you notice here, for a PDF file, you have it something like this, where you pass your MIME type application in the PDF and the type you pass there as a file. Earlier, if you remember, here we used to pass our type that was the image, and that was for a image file. As you notice here, if you remember, the type we passed here image. But this time, if we analyze our PDF document, we need to pass our type that is going to be the file type here. Having said that, let's go ahead and start analyzing our PDF document. So what we do here, first of all, we come here and then either we can copy this everything from here or we can start writing a fresh code. The PDF file which we are going to use here, I have provided with the code file. You can get it you can get it from the data and then RAG data, and then we are going to get here the Apple data. So we are going to choose here Apple 10Q Q1 24 data. So this particular data we are going to use. Let's go ahead and copy the path of this one. I'm going to get the relative path. If you open this file, you will see here you have total 28 pages in this PDF data. And this PDF data is going to be uploaded on Google LLM, basically Gemini model, and then we will be asking a question based on this particular PDF data. Let's go ahead and read this PDF data first of all. So I write it like this, PDF underscore bytes, and then I write it like this, open this PDF data, and either you convert this backward slash as a forward slash, or you write here R, that means raw path. You have a data, REG data, Apple, and then the Apple 10Q Q1 24 PDF data. And then you define here, read it into a binary mode, that is the RB, and thereafter we are going to read this whole data. Now if you notice here, you are having your PDF data and it starts with the PDF, and here is the whole data. Now we need to encode this data like we did earlier. So you are going to write it like this, byte PDF underscore base 64, and then base 64 dot encode base 64, not decode, this should be encode actually, and thereafter you pass your PDF bytes, and then you write it like this, decode, and then inside that you pass your UTF-8 here. All right, now you have your PDF base 64 data. Now you will notice this PDF byte got converted, basically this got encoded, and then you have your base 64 data, and that base 64 data is going to be something like this. All right, once you have your base 64 data, now it is time to prepare your MIME type. So we are going to write our MIME type. That MIME type is going to be exactly like this only. So you have MIME type is application and the PDF. Thereafter it is time to write your human message. So you write it like this, human underscore MSG, and then you have your human message. In the human message, you have here a list. In the list, first of all, you need to ask here a question, and this list is going to be the list of the dictionary. So you write your text here first of all. That text is actually your question here. Let's ask here a question, a simple question. I ask like this, summarize the key financial highlights from this quarterly report, let's say. This is my question. Basically, it is going to summarize all the financial highlights available in this particular PDF data. Now we need to pass our PDF data here, and we can pass our PDF data like this. You need to pass first of all your type, as we discussed here previously. The type is going to be here file type, and then you need to pass your base 64 data, and the base 64 data is a PDF base 64. Thereafter you pass your MIME type, and then you pass your MIME type here, and that is going to be like this. All right. So you have text like this, and then you have it like this. As you can see, now you have finally your human message here. Once you have this everything, now it is time to call your model. Let's go ahead and get the instance of your model. So we are going to use Gemini 2 model. So I just copy this from there and then I bring it here so that I can get the model instance. Let's run this. Thereafter, I can just simply write it like this: response equal to model dot invoke. Inside this, I can pass my system message and then I can pass my human message. If you don't want to pass the system message, it is perfectly fine. Later on, going down the line, we will not pass the system message. We will directly work with the human message. All right, because system message you need to pass when you have a complex queries, like we will be seeing later on in this course, where we will need system message for very detailed and very structured system prompt we will need later on. Let's run this. Now it's executing. Our PDF file data analysis is done. Let's go ahead and check the response. So here is the response. Response is AI message and here is the key financial detail. Let's check with the text data and then we are going to print it here. So we can just simply use like this, print response.text. With response.text, now we can see this whole output here. So as you see, like for 3 months ended on March 30, 2024, this is the financial year and all the detail is being printed here. And this really seems quite good detail and quite good analysis. I'm really super happy. I have verified the data. What I'm getting here is exactly the same data what I have here. So that verification part I have already done and this seems like really good analysis. So this is how you can analyze your PDF data with the Google Gemini model. But listen to me. Don't be too happy and don't be super happy. Now let me show you the problem with this. So what you have to do here, you need to come here, response, and then you need to search for here metadata. All right. So you have here usage metadata. Let's run this and then see the problem with this. Now, one thing you will notice here, the total number of tokens is like 10,000 tokens. All right. So this is a huge number of the tokens. For just this simple analysis, we have consumed almost 10,000 token. This is the problem. All right. So to solve this problem, what we can do? So there are two ways to do this. If you have a less number of the files, then you can use the context caching. So the context caching is something which we are going to see later on in this particular section. And let me just quickly show you here. So there is a long context problem. So if you have a long context, then you can do the context caching. So this is something which we will see later on in this particular section. Otherwise, you can use the RAG. So in RAG, what will happen here? You can pass the small chunks data so that you can actually reduce the total number of tokens utilization. Currently, we had just 28 pages. Because of that, we are just seeing like 10,000 of the tokens. But let's say if you have a very large file, something like this, where you have 100 pages or more than 100 pages, sometimes you might be having 1,000 pages. In that case, you might be having a problem. All right. So there are two solutions. Either you use the context caching or you use the RAG. And overall, this particular course is focused on a multi-agent deep RAG. Once we implement our deep RAG, then you will see that how you can reduce the total number of the token utilization. And also we will be able to improve the accuracy for a deeper query analysis or deep document analysis. All right. I hope that this overall course is helpful to you and you are following properly. If you have any doubt, you can ask that in the Q&A section. I would be really more than happy to help you. All right. This is all about in this lesson. I'll see you in next one. All right. Now it is time to see how you can attach tool with the Gemini model so that your Gemini model can call these tools. We had explored a couple of tools. We had created API key for these tools for Ollama web search and with the API. You can come here and see the Ollama API key. We had created our API key here. Thereafter, you can come to this docs here. In the docs, you can search for web search here. Let me just quickly search for that. You have your web search. This web search is going to be super simple to use here. Basically, you need to use this particular URL and then you call this web search API. Otherwise, we can directly use their Python library. The Python library is going to be something like this, where we import Ollama and thereafter we call Ollama.websearch. Before we call it, we have to make sure that we have loaded our environment variable, that is the Ollama API key. Once you have loaded this, then we are good to call the Ollama web search. Let's go ahead and write a code for that Ollama web search here. So I write it like this here: import OS. All these things later on we will need. So I'm importing this everything at the same place. So I import OS and thereafter I import the JSON as well. Thereafter, from LangChain dot tools import tool. Thereafter import Ollama and then import requests. So we will need this request later on as well. Let's go ahead and run this. Now you come back here and then you can just simply copy this whole code from here and then you can paste this whole code here. As you know that we have already loaded our environment variable in this notebook. Now we can just simply call this. Once you call this, you will notice you have got the output. That output is coming as the list of the web search result, and this web search takes here a 3 max result as a default parameter, and it also takes here a user query. All right. Let's go ahead and convert this everything as a LangChain tool. So what we can do here, we can just simply write here first of all a Python method, and then we can convert this Python method as a LangChain tool. You can write it like this: def wave underscore search, and then you can pass your query here. Now it is good to type hint your query so that your LM will understand that what is the type of input parameter. So I'm going to type hint my query, that is going to be the str here. And then it is also good to give here a proper docstring, because giving a docstring will enable your Gemini 3 model to understand when it need to call this particular tool and for what purpose it need to call. Thereafter, I need to decorate this with the tool. Once you decorate it with the tool, this particular Python method becomes here a LangChain tool. Thereafter, as I told you earlier, that you need to have here a proper docstring. So this docstring I have written here, so I'm just going to paste it here. This docstring is going to explain to your Gemini 3, perform a live search using Ollama Cloud Web Search API. Here is the search query and this is expected output. Basically, this is going to be passed to your API, basically your LLM, before calling this web search, so that as per requested prompt, LM will understand that when it need to call particular tool. Thereafter, this whole code comes here. We have already imported our Ollama, so we don't need that. Then our query comes in here, and that is here query, and the max result here I'm gonna set only the 2 max result so that I can reduce my API usage. Thereafter, here is my response. As you notice, your response is coming as a result, so I can write here like this: response dot results. Now I'm going to get the list of the output, that is going to be like this. As you scroll it here, you can see all this output here. All right, everything is there along with all the citations and everything. Thereafter, I can just simply return my response here. All right, perfect. Let's go ahead and test this tool. So I can just simply test this tool like this: invoke web search.invoke, and then I can pass my query here, and the query I can ask like this: what is the latest stock news, let's say. Let's go ahead and save this into a response and check my response here. Now I have my response here. As you notice here, I have got the output for this particular query, and now I can invoke my method. That means this method got converted as a LangChain tool. All right. So this is how you can write web search LangChain tool. In next lesson, I'll show you how you can write the Wither API tool. I'll see you then. All right, now it is time to create our Wither tool. So for Wither tool, we have already created API key, that is the Wither API key. Now we need to create a tool so that we can call this tool with our Gemini LM. So first of all, I write here a method. The method is going to be the get wither, and then I'll decorate that with the tool. Let's go ahead and write that. So I have already written the initial boilerplate code, so I just copy and paste it here. And this particular tool decorator is going to convert my standard Python method as LangChain tool. And then this location is going to be type hinted as str. That means our LM will know that whenever it need to call get wither, it need to pass this location as a string value. Thereafter, we provide here a doc string. So this doc string is very important with respect to the LM, because LM need to understand that when it need to call this particular tool. For example, if you notice here, our LM have access to these tools, and LM, unless you provide a proper doc string, LM will not know that when it need to call these tools and for what purpose it need to call. That is why providing a proper doc string is very important. And also it is very important to type hint your input parameters. Once you have all these things, thereafter it is going to be pretty much straightforward and simple. We need to build our URL first of all for Wither API. You can come here and search for Wither API URL, or in the dashboard, I guess you will be having here API Explorer. In the API Explorer, you can see, you can pass your API key and then the HTTP format, etc. And then finally you can get your API key. Let me just quickly see that. Where is that API key? Okay, not here. Let me just quickly give me my API key from here, and then I paste my API key here, and thereafter I'm going to ask here show response. All right, so it is going to give me the response here, and this response is coming for the London, that is by default. And here is the call which it has made. So this is something which we need to pass. All right, let's go ahead and copy this whole thing from here, and then we can modify that URL to build our own URL. So what we do here, we write it something like this, and then we paste our URL. This is overall URL which was called there. So you have HTTP basically, and thereafter api.witherapi.com v1 result v1 current.json. Thereafter you have your API key. So this is overall API key, and this is something where you can use formatted string methods os.getEnv, and here you can pass your environment variable API key name. So API key is with an API key. So this particular API key will be replaced there itself automatically in runtime. Thereafter you have your query, and this query could be location. So you can just simply modify this location, and then you can provide this location from here to here. And then you have your AQI no. So this is your URL. Let's go ahead and print this URL and see if you are going to get the correct URL. All right. So this location is coming from here, but what we can do here, currently we can just put here, we can just remove this location, and then you can clearly see here that this os.get environment is getting replaced. Similarly, this location will also get replaced, so don't worry about that. Now you will get here correct URL. Once you have URL, now it is time to just simply call this URL. As you saw here, that this URL was just getting called with the get API request, and then we were getting the output. That output was something like this. Location, name is the London, and then the region, country, latitude, longitude, and all the information is here. All right, cool. So that is how we need to do here. Then you can just call like this, response equal to requests dot get, and then you can pass your URL. Your URL is like this, and thereafter you can write timeout like 10. That means after 10 seconds it will give you the error like response did not, it did not receive the response. Then you have response dot raise for status. That means it is going to check for the response status 200. Unless it gets the response code 200, it will not succeed. Thereafter we get our data. The data is going to be like this, response.json. That means data will get converted as a JSON data, and then finally it is going to convert the data. It is going to return the data. Let's go ahead and run this. Now we have our get weather API. Get weather tool here. That is the LangChain tool. Let's go ahead and invoke this tool. We can just simply invoke this tool like this. We can pass our location, and this time I'm going to pass here location, that is the Mumbai. Let's go ahead and check the output, and here we get the output. Let's store this output in a variable that is going to be the response, and then check this variable. So here we have got our response. Name is the Mumbai, region is Maharashtra, country is India, latitude, longitude, and here everything is else. Here all the details are here. Now later on, what we will do in coming lesson, we will attach all these tools which we have just created, like Ollama web search tool and Weather API tool. All these will be attached with our LM, and then LM will call these tools in the runtime based on user input question or input prompt. Alright, this is all about in this lesson. I'll see you next one. Alright, so we have created our web search Ollama tool and Weather API tool, and we created these tools in our notebook. Now hypothetically suppose that if we need to use these tools in other files, then what you will do here? Either you have to copy this, otherwise you have to create a separate code file. Alright, just to avoid duplicate copy, what we are going to do now, we are going to create here a separate module. We will put all these tools in a separate module so that whenever we need these tools in other files, we will be able to call these tools right away. So what we'll do here, what we are going to do here basically, so we create here a scripts folder. Inside this scripts folder, we need to convert this script folder in a module. You can convert this by creating here init files like this, _init_.py. You just need to you just need to keep it as empty file. So basically, if you create this file inside this folder, now this folder will get converted as a Python module. Thereafter, I need to create here another file that I'm going to name as a base tool. Alright. Now inside this base tools, I'm going to provide, I'm going to copy and paste all these codes there itself so that I can just import my scripts inside this notebook, and then I can use these tools in the notebook. Not in this just notebook, but I can use these tools in any other notebooks as well. Let's copy this whole thing from here. Otherwise, I can just cut this with Control and X. I'm going to put it here. Thereafter, this whole thing, I need to just cut it from here and then paste it here. Alright, I have got my web search code here, and thereafter I can just simply cut this everything from here and then I can paste it here. So at the single place, now I'm having my web search tool and also my weather tool. Alright, perfect. Now if you have any other custom tools, you can bring your tool and you can write that tool in a base tools itself, and later on you can import this base tool in your notebook, and then you will be able to use these tools right away in your notebook. Let's go ahead and do that thing here. So what I'll do here now, from scripts import base tools. As you notice here, as you run it here, you will notice there is a PyCache that is created. Basically, this particular module is compiled, and now we are able to use this web search by accessing this base tools. Let's go ahead and access that. Now you can just simply write it like this, base tools dot web search. Basically, so base tool is here, and then inside that you have a web search. So base tool dot web search dot invoke. Everything is going to be as it is, like we had tested previously. Only thing is here, these LangChain tool we have moved in a base tool so that later on we can use these tool as it is. Let's run this. Now if you check the response, you should be able to get the output as it is. Similarly, what we are going to do here, we are going to just write here base tools dot get weather, because inside the base tool we have these two type of the tool, like we have our web search tool and also we have our get weather tool. Now we can just simply run it, and then we can check our response here. As we check the response, all the outputs we are getting here, as you see here, everything like wind mile per hour, kilometer per hour, the wind degree, everything, all the data which you see here, that is perfectly fine and that is correct data. Now it is time to see how you can attach these tools with your Gemini model. Let's go ahead and get our model instance. So we can get our model instance like this: chat, Google generative AI, and then we have our model, and we are using here Gemini 2.5 plus model. So we have got our model. Now we need to bind our tool with the models. How you can bind this? It is very much simple, like this: model with underscore tools equal to model dot bind tools, and then you can pass here list of the tools. As you see here, tools are going to be the sequence of the tools. So you pass here list of all the tools. All tools are defined inside the base tools. So I write like this: base tools dot web search, and then base tools dot wither dot get wither. All right, so these are the two tools which I have defined there. Let's run this. Thereafter, one important thing I want to show you here with model with the tools, you will notice here, let me just quickly show you here. You will notice it has the tool calling, that is the true, but as you scroll it down here, you will start seeing all the tools which is attached with this model, and then you have name of the tool, and then you have here a description. So this description, what you see, that is the doc string, and this is something which I have been telling you earlier when we were creating these tools. I was telling you that this doc string is going to be very important, because this doc string is serving as a description of the tool. With this, your LM or your Gemini model will decide when it need to call which particular tool at what time it need to call. So all these things will be decided in the runtime based on the tool's input parameters, and it's a doc string. All right, perfect. Thereafter, what you can do here, you can simply ask any question with your model. Then you can see that how model is calling your tool. So I'm going to ask here a simple question, like I write like this: response equal to like this, model with the tools dot invoke, and then I call like this: what is the weather in Mumbai, and what is the US stock news today? So the two questions I have asked in simple single query. Let's go ahead and see its output. One very important thing you are going to see here, which I'll explain you, that you are getting just single AI message. You are not getting any output here. In this AI message, what you are getting here, in additional keywords, you are getting just a function call. You are getting here a function call, that is the web search function call, and the query is here US stock news today. And then as you scroll it down, you will notice here list of the tool calls. You are getting get with the tool call with the location Mumbai, and another tool call you are getting, that is the web search tool call. With this, you are getting here a query, that is the US stock news today. And other than that, you see here this tool is not getting executed. So that is the problem. All right. So with the LLM, what happened here generally with the LLM, in fact, all the time with the LLM, what happened, as we saw in our introductory part, that the LLMs are a passive responder. LLM does not execute tools automatically. That is the part of the agent. Once we move ahead in this course, we will see our agents, and then we will see that how these tools are actually executed with the agent. Here, I just wanted to show you here a sneak peek how you can attach your tool with the LLM models. But once we start learning about the agent, then we will see their agent will automatically execute these tools. And after the execution of these tools, response of these tools will be returned as the tool message. And that is something we see here, that the response of these are going to be returned as a tool message. As of now, in this LM or this particular LM or any LM, what they can do max to max, they can just tell that which particular tool they need to call for a particular question. That's all. They cannot execute the tool. So you have to either write a separate code to execute the tool, like we saw earlier, like tool.invoke. Otherwise, we can wait for the agent, and then in the agent part, we will see that how all these tools are going to be executed. All these tracing, as usual, you can come here at the Langsmith, and then you can actually trace all these tracing here itself, and then you can see here that how all these things are getting used here. One thing you will notice in this chat Google generative AI output, web search tool is called, and also it says that the get with the tool is called here. All right, here was the input, and these are the input parameter passed to the tool calls. Location Mumbai for get weather, and for web search this was the user query which was passed. All right, I hope that you are following this particular lesson and this particular course quite well. If you have any doubt, you can ask that in the Q&A section. I would be more than happy to help you. And if you are not understanding something, don't worry about that. As we move forward in the course, you will definitely understand everything. So just stay tuned with the lessons and the lectures. Do not skip anything. Just keep learning. As you move forward, you will definitely feel comfortable with this course. All right. I'll see you next lesson. Hi everyone. Let's go ahead and see how you can control your model's thinking level. You have these parameters to control the thinking level. You can pass thinking budgets to control the maximum number of the tokens which will be used for the thinking. Then you have a thinking level which you can use to control whether it need to use the low thinking or high thinking. Otherwise, you can also use here include thoughts. Let's say if you want to support the thinking in your model and you don't want to show the thinking, reasoning steps, then you can make here include thoughts equal to the false. If you want to also show your thinking or reasoning tokens, then you can say that include thoughts equal to the true. In this particular response or in any of our previous response, we will not see any kind of the reasoning steps or any kind of the reasoning output basically. But our model had thought previously. Our model had used the thought or thinking labels basically. You will notice here that there are some tokens which got consumed because of this reasoning steps. Let's go ahead and see how you can control all these things here. So we need to create here a model instance like this, model equal to the chat Google generative AI. We can pass here our model that is going to be like this. Model is equal to the Gemini 2 model. Thereafter, we need to pass our thinking budget. So we can pass our thinking budget like this. Let's say we want to think only 100 tokens, basically max to max 100 tokens. Thereafter, let's say include underscore thoughts equal to the true. Now this is where you are going to see the difference. One thing it says that something is not available, maybe include thoughts that is not available, or maybe I had written it wrong probably. Yeah, it is now correct. Thereafter, we have our query here. So here is the query. Explain the theory of relativity in the simple terms. Let's go ahead and read it in the response. Basically, model output in the response. Model dot invoke, and then we pass our query here. That is going to be like this. Model dot invoke and the query. It is going to take some time to execute this. Then we can see our output in the response here. All right. In the response, you will notice here, it will be having the thoughts as well. Let's go ahead and see this. Now you will notice it is having here a thinking type, and also it is having the thought. If you check its a content block, you will notice it is going to have their thinking, that is the reasoning, and also it is going to have here text as well. You see, this is very important. All right. That is why LangChain has introduced this content block. If you have watched all the previous videos, I had very detailed discussion on the content blocks and the content of the LangChain. Because of that, LangChain has introduced this content blocks. Now we are able to see our reasoning steps, and also we are able to see our text step as well. Let's go ahead and see how many tokens it has utilized while thinking or while reasoning. That you can check here with the metadata, usage metadata. Now in the usage metadata, you will see reasoning is using only 98 tokens. We had already provided our thinking budget, that is the 100 tokens. So it cannot use more than 100 tokens for the reasoning. It can use only 98, max to max 100 tokens. All right. So this is how you can control the thinking of your model. Let's say you don't want your model to think at all, then how you can do that? You can basically set this thinking budget equal to the 0. In that case, your model is not going to think at all. Let's go ahead and check its response. And then finally, I want to print here response usage metadata. Let's run this and then see how much tokens it is going to use for a thinking. As you notice here that it does not have any thinking tokens now. The total number of the token utilization is around how much? Less than 900 total. It has 867, and you will notice it is not having any kind of the reasoning tokens at all. All right, so this is all about in this lesson. Now you know that how you can control the thinking level of your Gemini model. In case if you are using the Gemini 3 model, then you can also use there the thinking level as well. Instead of the thinking budget, what you have here, I would suggest if you are using Gemini 3 model, then you use thinking level high or low. Default thinking level in LangChain is high, but you can also use the low thinking as well if you want to save some tokens. But remember, using Gemini 3 Pro preview model is costly. That's the one thing. But if you have a free credits, or I'm sorry, if a free version is available, then it is perfectly fine. Otherwise, you can use here low reasoning so that you can consume less number of the tokens. All right, I hope that you are enjoying this particular course. So this is all about in this lesson. I'll see you in next one. Hi everyone, let's go ahead and see how you can use Google's built-in tools with your Gemini models. There are multiple tools provided by Google which is already inbuilt there in Google API. For example, you can use the Google search to ground your responses. You can use the Google Maps. You can build location-aware assistants. You can use the code execution that allows model to write and run Python code in a sandbox. You can also use the URL context, direct the model to read and analyze the content from a specific web page or document. You can also use the computer use, enable Gemini to view a screen and generate actions to interact. Otherwise, you can also use the file search. Basically, this is kind of enabling RAG with your document. All right, so these are the tools which Google provides as an inbuilt tool. In this particular lesson, we are going to focus on a Google search and the code execution. Let's go ahead and see how you can use these Google search and code execution with the LangChain and Gemini model. First of all, we need to create our model instance. We create our model instance like this. Although we have created it multiple times before, I just want to create it once again like this. I have Gemini 2 model. We have got our model instance. Now it is time to bind these inbuilt tool with our model. So we can do it like this. Model with tools equal to model dot bind tools, and then in this bind tool we are going to provide a list of the tools which we want to bind here. So first of all, we have here a tool. The name of that tool is Google search. This tool name need to be like this only because this is inbuilt tool, and we don't need to pass any parameter here. We can keep this as it is like this. Thereafter, another tool which we are going to use, that is the code execution tool. So we write it like this, code execution, and its value is going to be the empty dictionary. That is something like this. Now we have our model with the tools. Let's copy this and paste it here. Now here we have our model with the tools. Total number of tokens, we have 1 million. The max output tokens, image inputs, and all these things we have here, as you can see here. All right, all the details. Now this particular model with tools is ready to use with these inbuilt tool. Let's go ahead and ask question. So here is our query. Now this particular query I'm going to fire with my model with the tools. I write it like this. You have your response equal to model with tools dot invoke, and in that you need to pass your query. Let's run this and wait for some time. As you see here, execution is done. Let's go ahead and check our response.content block. We are going to check our content block. Now we have got our output, and this is our final output. So one thing we notice in our output that this is not using our Google search because the type of the question we asked, that type of question does not need a Google search. Let's go ahead and ask another question which could relate to a Google search. And also I'm going to ask here a question where Google need to do code execution basically. So question is very simple. When is the next total solar eclipse in the US, and also what is 3 plus 2? So for this part, it is going to use the code execution, and for this one, it is going to use the Google search. Let's run this and then see what happened here. It is gonna fire a Google search, and also it is gonna fire, the code execution. So here it says some kind of the warning, output may vary each run. Yeah, that is perfectly fine, because we know that output can change because this is AI. Let's go ahead and see its output. So in output, it says the answer is 5. And for total solar eclipse, I'll use the search tool. As you see here that it is using the search tool, executable code first of all. So basically what it has done here, it is using code execution for searching as well. This seems weird, but one thing is 100% sure, that it is doing all, it is using inbuilt tools. And then finally, it has used, as you see here, all kind of color, space, etc. So seems like what it has done internally, although it is using the Google search, but somehow it has written a code internally, and thereafter it has scraped some kind of the web page, seems like, because I see a lot of HTML and the CSS code in the response, and then finally it has given the thought signature and final output. Also, it has performed here web search queries like next total solar eclipse in the US, and all these stuffs it has done, all right, to find out the correct output. All right, excellent. Now you can see that our Gemini model is using here inbuilt tool. You can use here text to find out final text data, and then you can print this response.text data. So you can do it like this, and here you have here. All right, perfect. Let's go ahead and check your response.content block just to understand that how much information it has here. So in the content block, you have here a text, and this is the text. That's the first text. What it does here, by default, it did not use any kind of the tool to identify 3 plus 2. All right, so the code execution was not used, but if you ask a complex question, it will definitely use code execution. But for this particular question, it decides to use the code execution. That seems a little bit weird to me, but anyway, it has used there a Python code, all right, for this particular question. Thereafter, it decided to use the other tools, and seems like looking up information on Google search. Yeah, here it is, web search it has used, and then finally it has found out here final answer, and then it is producing, it has generated the final answer. Seems like everything is working perfectly fine. So all the tools which we see here, all right, you can utilize these tools with the Gemini app or Gemini LLM. We have used here Google search and the code execution. Other tools you can test by yourself, but generally we don't need in this particular course. That is why that those tools are out of scope in this particular course. All right, so this is all about in this lesson. I'll see you in next one. All right, now let's go ahead and see how you can cache the context. This is something which we had discussed when we were working with our PDF file. At that time, we saw that our PDF file was utilizing so many tokens for each question. If you scroll it here at the top and just see the PDF file, here was the PDF file, and in the response, we can see here that many tokens are getting utilized. And in the cache token, we are getting 0 token. Let's say if we have 100 of the question to ask, then every time we will upload this PDF there, that means 100 into 10,000, it is going to consume almost, almost 1 million tokens. All right. So to solve that problem, what we can do here, we can actually use here a context caching. So in context caching, what will happen here, it is going to save some context on the Google server itself, and then it is going to utilize those context whenever we refer the same context. All right, let's go ahead and see how you can do that. But before we move ahead, let's see how much cost we can save with the context caching. So here is the detail for the context caching. So in the context caching, you have, for Gemini 3 model, normal usage are listed here, but context caching use is listed here. You have $0.2 for a prompt for a per million token, if total number of tokens is less than 200k, or if it is greater than 200k, then it is going to be costed with this particular pricing. And then here is the usage. So it is going to consume $4.5, all right, for a million token if you want to store that in its cache system. Basically, we will be having here option to store our caching for 1 hour, 2 hour, 30 second, 3 second, or whatever you select. All right, for that many hours your context is going to be stored in the server, and then your LLM is going to store that, all right, for you. All right, so you have to optimize your operation in that way, because here reusing the context is going to be super, super simple, and also it is going to be super cheap for you. But but storing those context in the LLM is going to be costly. All right, even after that, you will notice here the overall cost is a lot lesser than what we see here. All right, so all these things you can keep in your mind while you are storing your context at the Google server or in your Gemini LLM. Thereafter, you scroll it here down, you can see the context caching for other models as well, like Gemini 2.5 Pro model have the context caching pricing here, and then Gemini 2.5 Flash have context caching pricing here. So the context caching pricing for Gemini 2.5 Flash model is really quite less. It is just $1 for 1 million token for 1 hour. Let's say if we store it for 30 minutes, then it is going to consume $0.5 for 1 million token. All right, cool. I hope that overall pricing for the context caching is super clear to you. Let's go ahead and get started with the coding part now. And link for the resources like the caching guide and the pricing detail link is also given in the notebook. You can visit here. First of all, one need you need to understand here that this caching etc. does not come with the LangChain. So what we will do here, we are going to use Google's native generative AI library. So we'll be using Google library itself to enable our caching here. All right, I hope that you have already installed the requirements.txt. So you already have your Google generative AI installed in your computer. Let's use this. So I import it like this. First of all, time import. Thereafter, from Google, import GenAI. Thereafter, from Google dot GenAI dot types, and then I'm going to import here create cache content config, and then create content, and also I'm also going to import here part as well. You see here all these things are going to be used to create our caching. All right, let's run this. Now we have imported all necessary library. Let's go ahead and create our client. So we create our client like this, GenAI.client, and then we do it like this. One more thing you will notice here, API key, we are not passing anything, but if you want to pass it separately, you can pass it. Since we have already loaded our API key in environment variable, we don't need to pass that API key separately. Let's run this. Now we have our client here. All right. So this client is now going to be used to upload our PDF file. We had tested our PDF file previously, this one. Now in coming lesson, I'll show you how you can upload multiple PDF file and then how you can refer these file using context caching. All right, I'll see you in next lesson. All right, so we are going to upload these file in our Gemini model context. So these files are available here in your data, and then the RAG data inside the Apple, you have Apple 10Q, Q124, and then Q224. You can bring your own PDF file if you want, but these PDFs are provided with the course file itself. So these are the file path. Let's go ahead and write here a for loop to upload these in Google context. I mean Google's Gemini LLM context. So I write it like this. First of all, uploaded files. I need to maintain here a list that how many files are uploaded, and then for path in file paths, and then I can say it like this: file equal to client dot files dot upload, and then I can write it like this: upload file is equal to path. So with this, what we are going to do, first of all, we are going to upload these on a Google server. Thereafter, we keep uploading file until we get a status equal to success. So we keep uploading. By the time we are having status equal to the processing, state dot name equal to processing. All right, until it is processing, it will keep uploading this. Thereafter, we are going to wait here for 2 seconds. So time dot sleep, wait for 2 seconds. Thereafter, again check here, file equal to client dot files dot get, and then you have your name equal to file dot name. All right, once your file processing is done, thereafter you are free to store this file name in uploaded files. So you write it like this, and then you see that your file is uploaded on the Google server. Let's go ahead and run this. Thereafter, we can check our uploaded files. With this, we can monitor that how many files have been uploaded on the Google server. Now we know that all these files are uploaded, and we have got our file instances as well. As you see, all these files are uploaded. Application PDF file is there, and these are the temporary name created there at the Google site, and all the SHA, everything is basically given here, which you need to know. As you notice here that it has uploaded these files on the Google server as well. All right, perfect. All these files are uploaded on the Google server. Now it is time to create LLM cache using these files. All right, let's go ahead and create the LLM cache. Here, what we are going to do, we are going to actually upload it for 1800 seconds. That means we are going to store our file in the cache system for 30 minutes so that we can complete our remaining lessons as well. All right, cool. Let's go ahead and upload. Basically, file upload has been done. Now it is time to create the cache system. So create a cache system is going to be created in parts. So I write it like this: parts equal to empty list for f in uploaded files. All right, basically I'm iterating over these uploaded files, what you have here. All right, these uploaded files are going to be iterated here. Then I write it like this: part is equal to part. So this part we imported earlier from our Google Gemini. Here it is, and the content is also there. All right, so we have it like this: part equal to part dot from URI, and this URI is coming from our uploaded files. Then we write like this: file URI equal to f dot URI, and that URI is this one. That means it is going to basically create a cache system from our uploaded files URI. It is going to be like this, and thereafter MIME type it is going to use here. That MIME type is f dot MIME underscore type. So this MIME type we have already discussed previously, and also you can see this MIME type here as well, application PDF. Now we have got our part here basically. All right, for first file, and thereafter we are going to store it into the parts dot append this particular part here. With this we have got our files here. Thereafter we need to prepare our content. So this content is going to be like this. This content need to be in the format like Google Gemini accepts. So it is going to be like this: content, and then in this we write like this: role is user, and then parts are going to be here, parts. All right, all the files content is created here. Let's go ahead and check our content. So we check our content like this. Here is the content. All right, everything is here. Now it is ready to, basically what I would say here. Now it is ready for creating our context caching. I guess now I got it rightly. Cool. Okay, so you have your content. Now it is time to write the final piece of the code. So we can write it like this: cache is equal to client dot caches dot create, and then we need to use here a model for which we want to create the cache system. Let's say we want to create it for Gemini 2 model. We write it like this: model equal to Gemini 2, then config equal to create cache content config. All right. In this create content cache config, we need to pass here some information for our the cache system, like this display name. This display name is going to be here, just a string, so that we know that what type of content we are actually caching. So I write it like this: Apple Q1 Q2 2024 reports, let's say. Now we know that this kind of the data we are actually caching here, and this should be like this: display name equal to like this. All right. Thereafter, there is going to be the system instruction. While caching, what should be the system instruction? So system instruction is straightforward. So I'm just gonna copy that and put it here. Like, you are a financial analyst, use these Apple quarterly reports to answer the question. That means when your LM hit these cache, it is also going to retrieve this system instruction as well. And then we are also going to pass our contents which we had created previously. That content is here. Let's go ahead and provide here a TTL. This is time to live here. And we discussed that we are going to store it for a 30 second. That means we need to pass here 1800s. That means we need to pass it for 30 minutes basically, not a 30 second. All right, let's go ahead and run this. Now our cache is created. We can check this cache here. So here is cache, and these are the cached content. Everything is here. There is the total, the token count, 14,465 tokens are getting stored. Basically, these are stored now in my Gemini 2.5 Plus cache system. Now, if I hit my Gemini 2 with this cache address, then we will not get charged here. All right. And here is the name of our cache data. This is like a unique identifier. In coming lesson, I'll show you how you can hit your cache system. I'll see you then. All right. So in our previous lesson, we had seen that how you can upload your document in the context cache. Here is the unique name. This unique identifier we can use to query our context cache. So what we do here, first of all, we come here and then we create our model. That model is going to be like this: model equal to chat Google generative AI. And in this, we have our model, and that goes like this: Gemini 2. And thereafter, we have our cached content here. Basically, we can write it like this: cached content. In the cached content, we can write like cache.name. All right. Here is the unique identifier. That means whenever we call this particular model, it is also going to refer this particular context cached context as well for the context data. Let's go ahead and get our model. Now we have got our model. Now it is time to ask here a question. So very simple query I have here. That the query is like, compare the revenue growth between Q1 and Q2 of 2024. All right, let's go ahead and ask this with our model. Response equal to model dot invoke, and then we pass this particular query here. That's all I have to do here. Let's run this. While it is running, let's go ahead and write a code to display our data in a markdown format. I can write it like this: from I Python dot display import markdown and display, and then I can display my data in markdown rendered format here. That I can do it like this: response dot text data, and here I have got my output here. Seems like parsing is not getting done here properly, but anyway, I can see here a proper output here. As you see here, it is comparing the revenue growth between the Q1 and Q2 of 2024, and we have not specified here any kind of the document or anything. But you will notice here it is comparing Apple's fiscal quarter. All right, that means it is using the same document which we had uploaded previously and from the context. Now, one important part here I want to show you here, that is the response. So in the response dot usage metadata, you will notice here that it is using a lot of tokens from the cache itself. So it is using 14,465 token from the caching itself. Although it says that these are the many tokens it has utilized, but all these tokens are not going to be charged to you. Only these many tokens, and whatever the difference you have this and this, because these many tokens are already coming from the caching itself. All right, so these tokens are not getting to be charged for you for this particular request. These tokens are getting to be charged with this particular rate. Here is the rate. If I store 1 million tokens for 1 hour, then I'll be getting charged with $1. So you will notice here that there is a huge difference between the costing. That is why this context caching really helped. And the context caching also makes your model super fast because it don't need to parse all this caching every time from the starting. Let's go ahead and test this with second query. I have here a second query that is going to be a very detailed query, and that query I'll be using later on to generate the infographic with our Nano Banana Pro model. So here I have my query. I store my query like this. You can press Alt and Z in your keyboard. With this, you can wrap this. Provide a detailed analysis of Apple's Q1 and Q2 24 earning with the key financial metrics, revenue comparison, and growth trends. Format this as a bullet point suitable for infographics. This is a very important question. Let's go ahead and ask here with the model. So you have a model dot invoke, and then we are going to pass our query here. Let's run this. Now we are going to get the output, and here is the output in the response. And we are going to print here, instead of markdown, we are going to use here print response.text. Apart from that, we are also going to see here usage metadata as well. We can check it like this, usage metadata. Once this execution is complete, then we will be able to see these output. As you can see here that it is still reading a lot of the content from the cache itself. All right, and these mini tokens it has used for the reasoning, and here is the tokens which it has utilized for generating the output. And this time you will notice here it is having a lot better output than the previous one. Why? Because we have provided a question in that way. All right, your question need to be accurate, otherwise you might not get a good output. All right, perfect. So this particular output later on we will use with our infographic. Now, what type of infographic I'm telling here? Let me just quickly tell you before we move forward. So in the coming lesson, I'll show you how you can generate the image using Gemini 3 Pro Preview, a Pro Image Preview model. That is also referred as here a Nano Banana Pro model. All right, we are going to use this model to generate a very good financial infographic. I'll tell you in next lesson. I'll see you then. All right, now we are going to see how you can generate the image using Google's Nano Banana Pro model, and we are going to generate here infographic image. Let me just quickly give you a sneak peek what we are going to design here, basically what we are going to generate here. You see here how good it is. This is super impressive. So this is something which we are going to generate with Google's Nano Banana Pro model. So in this particular image, we have utilized here our, the cache system. So where we have uploaded our PDF document, we will be asking a question. Basically, we had already asked here and we have got the response. This particular response will be passed to our Google Nano Banana Pro model. And then Google Nano Banana Pro model is going to generate an infographic, something like this, that is going to be super good. All right, let's go ahead and get started with this. Okay, one more thing before I get started with this, I have provided here a link for an LangChain Google issue. Basically what happened here with the LangChain API, they generally don't provide you ability to change the aspect ratio and the resolution. By default, you will be having 1K and 16 by 9 aspect ratio setup as a default one. They have opened here an issue. Once this issue is resolved, then you can change other aspects ratio and the resolution as well. But for now, let's go ahead and see with 16:9 and 1K resolution. All right, cool. Let's go ahead and import necessary packages. First of all, I need to import here our modality from LangChain, Google Gemini, import modality. What is the modality? In this particular image, you will see two mode here. One is the image itself, and the other one is the text data. That means it is a multimodal output. Okay. Thereafter, we are going to define here aspect ratio. Although we already know that default aspect ratio currently we are having 16:9 only, but still we define here for a reference. So we define here 16:9 as a default aspect ratio. Then we have our resolution here. With the resolution, we are going to have here a 4K resolution or 1K resolution basically, because it doesn't provide any option as of now to change. Once this particular thing is resolved, then you can change the resolution and aspect ratio as defined here. All right, let's go ahead and create our image model. So we write it like this: image model equal to chat Google generative AI, and then we pass our model name here. This time we are going to use our Gemini 3 Pro image preview model. This particular model is referred as a Google Nano Banana Pro model. All right. So we have Gemini 3 Pro image preview model. Thereafter, we are going to provide here image content. What is the image content here? So image content which we had here previously, that we are also going to provide this one. This whole thing we will provide response.text data. Along with that, we are also going to provide here a little bit instruction here. Let's go ahead and provide that. So a small instruction we provide, like create a professional infographic with this data. And here is the data, right? Now, if you run this and you check this image content, you will be seeing this image content here. So this is a text data. All right, this is additional text data which I added here. Thereafter, this is previous text data. This whole image content is going to be passed to our Google Nano Banana Pro model, and then it is going to generate the image here. All right, cool. Let's go ahead and get the output. So we have here image underscore response equal to image model dot invoke, and then we are going to pass here image content, that is our text data. Thereafter, we are going to tell our LM that we are expecting here a response modality. All right, that is going to be like this. Response modality is we are expecting here, that is going to be the text data modality dot text and also modality dot image. All right, so these are the two modality which we are expecting currently. Let's go ahead and run this. Now it is going to take some time. Once it finished, then it is going to generate this beautiful infographic for you. Let's wait for some time. Now the execution is done here. We have got our image response. Let's go ahead and run this. In image response, you are having here AI image, and then you are having here the type, that is the image URL, and here is the image URL, and then there is the URL. Do you remember this is something which we have used previously? This is base 64 encoded data. We can check this with the content block as well. We can check it like this: image response dot content block. In the content block, we are having here data. Now in this content block, this is our data, and this is something which we need to store here. All right, perfect. First of all, let's go ahead and display this image data. So this we can image, this is something which we can actually display like this. With the 0, we will be getting this one, and then with base 64, not this one. We can copy this one, I guess. I hope we can copy. Yeah, with this we get our base 64 data. Now, once you have your base 64 data, now you can actually display this base 64 data, and that you can display with like this, display, and then you can pass here image, and in the image you can pass this, and now it is going to display this. Let's run this. Seems like image is not defined. That image we need to define. Let's define that image first of all here. So we write it like this: from ipython.display import image. Let's run this. Now we need to run this, and here we are going to see the image. Seems like still something is wrong. Let me just see here, no such file or directory it is saying here. Okay, so what we have to do here, basically this image we have to decode first of all. All right, so this whole thing is not decoded yet. We have to decode it. Let's go ahead and decode this. So what we do here, we write it like this: base 64 dot base 64 decode, and inside that we need to pass this image. Let's go ahead and run this. Now you can see this image. Wow, this is beautiful. Here I had original image, and here is this one. This is awesome, right? Now you can use this in your presentation, in your project, and your boss or your professor is going to be super impressed with you. All right, excellent. Now you can just simply save this image wherever you want. You can save this. Otherwise, if you want to save this programmatically, then you can also save this programmatically as well. How you can save this? Basically, you can take this whole thing from here. Whatever you have, this everything, you just take it from here. Thereafter, you just need to write here a code like this with open. Where we want to store it? We want to store it inside the data, and then we have inside images, and then you can write here like appleinfo.png. All right, and then we are going to write here a binary file as f, and that's all you have to do here, f.write, and inside that you need to provide base.64 base 64 decode, and this is whole data. Let's run this and then see your data is stored here. You see here, this is awesome. I'm sure you are super impressed with this, and I hope that you are liking this particular course and this overall, the section. You have liked this. I have one request to you. Please come to my YouTube channel here at KGP Talkie and subscribe this channel so that whenever I publish new video, you would be able to get the latest update. The other thing I request to you, please do not forget to leave your feedback and rating of the course. It will really help me to improve myself, and also it will really motivate me to make more courses for you. All right, I'll see you next lesson.